All right, so this is lesson 1.2. We're going to talk about line segments. We're going to talk about measuring line segments, and we're going to talk about between. So unlike a line, which has no endpoints and goes on forever, a line segment can be measured because it has two endpoints. When we talk about the measure of a segment, we're talking about the distance. We want to know the distance from point A to point B. We do not put a bar over it. So you have line segment AB. And if we want to find the measure of that, we just say that AB, the distance from A to B, with no segment on the top, equals, and I'm pretty sure that looks to be about 42 millimeters. So why are we able to measure a line segment? Because line segments have two endpoints. They don't go on forever. All right, next. Between. Now, the betweenness of points says that a point is between two other points. So for example, point M, the definition, point M is between points P and Q if and only if P, Q, and M are collinear and the distance from P to M plus the distance from M to Q equals the distance from P to Q. So let's just take that definition, the definition of betweenness, and let's first of all draw a picture. So point P, point M, and point Q. So the definition of betweenness says that M is between P and Q if and only if all 3 points are collinear. You see that all 3 points lie in the same line, so they are collinear, and the distance from P to M plus the distance from M to Q has to equal the distance from P to Q. And if we were just to give some arbitrary measures, like if I said, well, that PM is 4 and MQ is 2, well, is 4 plus 2 the whole measure of PQ? Yes, and that equals 6. So that's true. So that's what this is saying, okay? That's all that the definition of betweenness is saying. So we're going to use that information, and we are going to figure out, we're going to actually do kind of like an algebraic proof maybe. So we're going to start proofs. This is just a real basic proof here. But when we do a proof, we start off with 2 columns. So we're going to find x and z. Sorry, we're going to find the distance from x to z, and we're going to assume that the figure is not drawn to scale. So we're going to do this algebraically using an algebraic proof. So when we do that, we start off with statements, and then we have reasons. All right. So statement number 1. Well, I can look at that figure and I know that x, y, and z are all in a straight line, so that means that they are collinear. And that, the reason I can say that is just the definition of collinear. Okay? The next thing that I can say is that y is between x and z. And that is the definition of betweenness. And then I could say that Because y is between x and z, that means that xy plus yz equals xz. And that's segment addition. We're just adding the segments together, segment addition. And then I could say substitution. Well, what is the value of xy? Xy has the measure 4 5/8 plus what does yz? Yz has the measure of 2 1/2 equals the measure of xz. We don't know what that is. We're trying to find it. And that is just substitution. I just substituted in values. So substitution. And then I'm just going to do some basic addition. 4 5/8 plus 2 and, I'm going to sneak that into a 4/8. Well, 2 plus 4 is 6 and 9/8, which is the same thing as 7 1/8 equals xz. And that was just basic addition. You could even say it was simplify. So what is the measure of xz? Well, xz is 7 1/8. So that would be a basic 2-column algebraic proof. I know that you could have done that just by adding those two together. I just wanted to show you what that looks like. All right. So now we're going to find the value of n and wx if w is between x and y. So I'm just going to draw a segment. I know that w is between x and y. I don't know exactly where it is, but I know that wx equals 6n minus 10, and I know that xy, this whole value right here, equals 17. And I know that wy equals 3n. So because w is between x and y and they are collinear, I can say that 6n minus 10 plus 3n must equal 17. Combine like terms, 6n and 3n is 9n. 9n minus 10 equals 17. I'm going to add 10 to both sides. 9n equals 27. Divide both sides by 9. N equals 3. So we were asked to find the value of n, and n equals 3, but we were also asked to find the value of wx. So I'm going to take the value of n and plug it in. So wx is 6 times n minus 10, which is 18 minus 10, or 8. Okay, so not doing anything too hard, I don't think. Really just doing some substitution with algebraic expressions. All right, so now let's talk about congruent segments. Congruent segments have the same measure. So if I were to tell you that segment AB was congruent to segment AD, I'm going to try and draw AB, CD. If I were to tell you that these two are congruent to each other, they would have to have the same measure. So I would have to say that 2x equals 4, which would let me know that x equals 2. Because remember, we said that AB is congruent to CD. Segment AB is congruent to segment CD, which means that the distance from A to B has to be equal to the distance from C to D. So if segments are congruent, that means they have the same measure. So I use this symbol right here and it's basically an equal sign with the little tilde symbol over the top of it. It is not the Spanish equal. I used to have kids say that all the time. It is not the Spanish equal sign. This is the symbol for congruent. Okay. So let's see if we can solve this one. It says AB equals 4x, BC equals 9x minus 4, AC equals 14x minus 7, and we have to find x, AB, BC, and AC, and we're missing something really important here. And it's just written on my notes or on our smart file. So if we were actually in a class, you would see in our smart file that there's a little asterisk and it says B is between A and C. So I'm going to draw that just because I am a visual learner and I like to have pictures. A, I'm going to put B right here, and C. So now I'm going to do some measures. Let's see. I know that AB equals 4x. I know that BC equals 9x minus 4. And AC, this whole thing right here, is 14x minus 7. So we need to solve for x and do some substituting. Well, that means that 4x plus 9x minus 4 must equal 14x minus 7. Let's combine some like terms. 4x and 9x is 13x. 13x minus 4 equals 14x minus 7. So I'm going to subtract 13x from both sides, and I'm going to add 7x to both sides. And I'm going to do it really without showing any work. So let me say again what I'm doing. Subtracting 13x from both sides, that leaves me with x. And adding 7 to both sides, that leaves me with 3. So I know that x equals 3, so I solved that. That means that segment AB has to equal, well, 4 times 3 is 12. And that means that segment BC, which is 9 times 3 minus 4, well, 9 times 3 is 27, minus 4 is 27 minus 4 is 23. Okay, and AC, I'm going to squeeze that down here. AC is 14x minus 7. Well, 14 times 3 is 42. Minus 7 is 35. And I certainly hope that AB plus BC, 12 plus 23 equals 35. And it does. That means that we figured it out correctly, okay? So the last thing that you have is your homework. I'm going to tell you that your homework for today is out of your textbook, and it is on page 18. I want you to draw images when needed. I want you to show your work. And your problems are listed in Canvas. Problems in Canvas. Okay. This is due on Wednesday at the beginning of class. Good luck.